Given a positive integer n and a real number k, consider the following equation in x. X minus 1 times x minus 2 times x minus 3 up to x minus n is equal to k. Which of the following statements about this equation is true? And there are 4 statements here. Okay, then it looks like, so n is an integer, k is a real number. I haven't read all the options in detail here, but it looks like the one key to understanding this is going to be about even and odd even and odd degreed polynomials and whether they can have solutions or must have solutions. So option A, for example, if n is equal to 3, then the equation has no real solution x for some values of k. This is false, because if n is equal to 3, then it's a third degree polynomial, and the range of a third degree polynomial is the entire real line, so that'll always have a solution. So we can rule out A right away. A third degree polynomial looks something like that in general, right? It's always going to go off to negative infinity and up to positive infinity as x goes to the left or the right. B, if n is even, then the equation has a real solution for any given value of k. This is also false. Would not be difficult to construct examples, right? If n is even, in particular, if n is equal to 2, well, what will the polynomial look like? It'll have roots at 1, and 2, and it'll open upwards. So it'll look like that. And so for values of k down here, there's no solution. So B we can eliminate. If k is greater than or equal to 0, then the equation has at least one real solution. I'm tempted to say that this is true, and I'll come back to my reasoning in a moment. Let's look at option D first, though. The equation never has a repeated solution for x for any given values of k and n. This is certainly false. We can see that even from this example here. If n is equal to 2 and k is a positive number, then we could potentially have two solutions, two values of x. Okay, let's look at option C and see why this has to be true. Okay. Well, if k is equal to 0, well, let's just look at what this polynomial might look like. So it has roots. The polynomial has roots at all the integers from 1 to n, right? So it's 0 at all these values up to n. And to the right of n, if x is greater than n, then this term is positive, and all of these are in fact positive. And we never come back down to 0, so we kind of, the polynomial will blow up to infinity in this direction. And so any horizontal line that I draw for, which is non-negative, will intersect this polynomial somewhere for a value of x greater than n. So option C is the correct one. The others are false for, if you just understand, think of the thing on the left-hand side of the equal sign as being a function of x. And if you understand what that function is going to look like, depending on whether the degree of the polynomial is even or odd, you can rule out options A, B, and D just from knowing about that. Yeah, this one wasn't really too difficult compared to some of the other ones on this admissions test. But if I have more to say about it, I'll put it down in the description. Thanks for watching.